All right.
Those things are terrifying.
Are we ready, spaghetti?
I don't have a budget.
I want to look at maybe one of these like maybe like number 6 or something, or
11.
I'll go over 11. I'm going to be going over 11, like the graph ones. Those will be pretty quick, actually. And then I will go over some general stuff
I
here.
left mine at home.
So, what did I say? 6? 6 looks pretty good. 6. Okay, you got f of x and g of x. What would it look like if you went f of, first, what's f of smiley face? F of smiley face would be smiley face squared plus 5. The idea being, if you have f of something, it's just that something squared plus 5, right? So what happens if you go f of g of x? Well, you have g of x squared plus 5. Do we all feel okay about that? So in this case, g of x is the function 1 over the square root of x minus 2. We okay with that? Now, you got to kind of stop right here and go, well, wait a second. There's going to be a domain restriction because of this square root. So before we write our final expression, what's the domain of this function? X has to be what kind of number for it to go into this? It has to be greater than 2. Why can't it be 2? What?
Because then it'd be 0.
You'd be dividing by 0, right? So x can't be less than 2 because you'd be square rooting a negative, but it also can't be 2 because you'd be dividing by 0. However, when you simplify this, you get 1 over x minus 2 plus 5. There's a little bit of an issue here.
You need to include the domain?
You need to include the domain restriction, because if someone looked at this, if you told them f of g of x is 1 over x minus 2 plus 5, they would think that x can be, for example, can x be 0? They would think that, but x cannot be 0. So you have to actually include this domain restriction as part of your function. Are there any questions on why this is necessary? Or where it comes from, or really any questions at all, I guess. Are there any questions at all?
No.
Wait, so why is it included?
Because if you don't have so once you have this established, the domain from this step, you then have to look at what you end up with and say, well, is it obvious from looking at this that x isn't allowed to be less than 2? It's not, because if you looked at this, you'd think the domain was all x values except for just 2. So because the domain is actually only numbers bigger than 2, you have to actually throw that in as part of the function. Because like without the domain restriction, that graph would look like this. Which I'm sure you guys all remember this. Asthma Pope at 5, Asthma Pope at 2, and it'll be like this, something like that. But wait a second. What part of this graph isn't actually included in this graph? This whole thing isn't actually part of the graph. So f of g of x is actually just this thing here. And that's handled by this domain restriction. Why'd you shade in those things?
Not shaded in, there's cool designs on it.
They look cool.
Okay. How about g of f of x? Let's go the other way.
Sounds like a Dr. Seuss character.
G of f of x.
G of f of x.
I see what you mean. So g of f of x would be 1 over the square root of, you just replace the x with this thing, right? Everyone cool beans with that? Cool beans all around? Okay. So it's this 1 over the square root of x squared plus 5 minus 2, which is 1 over the square root of x squared plus 3. We understand that?
No.
No?
I got lost somewhere at the beginning.
Okay. G of x is 1 over the square root of x minus 2.
Oh, I'm on the wrong problem. Never mind. I've solved my problem. Forget.
I see that would be confusing.
Okay, what's the domain of this?
X is greater.
This is greater than 3. No.
X does not equal.
What, Alethea? Very good.
Wait, what?
Oh,
Yeah, because it's squared, so even if we put
No
in a
dimension.
negative.
Oh.
Is there any way to make this expression be 0?
No.
Nope, because that x squared is always going to be 0 or greater, 0 or positive. So the smallest number, the least number that this can produce is 3, which means it also can't go negative. So you never have to worry. There's no x value that can make this be a negative under the square root or a 0 on the bottom of the fraction. So therefore, the domain is anything you like, any number. Okay. Here's a fancy question for you fancy thinkers. True or false?
True.
Function composition is commutative.
false.
True.
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 False. True.
True or false? Function composition is commutative.
Means you can move things.
Anyone feel confident they know the answer?
No.
No? It's false.
Let's go. I knew it.
Who can name something that is commutative?
Addition.
Addition, there you go. 2
Yeah.
plus 3 is the same as 3 plus 2. What?
Multiplication.
Multiplication of numbers, not of matrices.
Wait, what?
You know what a matrix is?
Matrix.
It's like an array of numbers.
Oh,
So like a matrix would look, for example, like 2, 5, negative 3, 1. That's a matrix. You can actually multiply a matrix by a matrix. But matrix multiplication, you can't, if you swap the matrices, you end up with a different answer. But multiplication of numbers is commutative. 5 times 7 is the same as 7 times 5. So do you guys see why function composition is not commutative? Look at the last question. Was f of g of x the same as g of f of x? Definitely not the same. All right, I want to look at 9 with you guys, because 9 has some weirdness to it, even though it seems really easy. So on 9,
Sure.
okay. Are you catching this stuff?
Mhm.
Should we pay attention?
What do you think of?
Did you do it right? So I should listen. Make sure you're right. What's f of g of x?
X.
It's the square root. What's f of banana?
Yeah.
Square root of banana. Hey. So f of g of x would be the square root of the g of x, which is like saying the square root of x squared. Everyone okay with that logic there? And Zach said it. the square root of x squared is the absolute value of x. Okay. What's the domain of that function?
All real.
All real. Okay. Does you all understand this? If x was -5, you go -5 squared, 25, square root of 25 is 5. So this function actually turns negative numbers into their positive versions of themselves, which is exactly what, and it would take a positive number and leave it unchanged. So if you plugged in +5, you get +5 out. So that's what the absolute value function is. How about, the next one's even weirder. G of f of x. Well, g of x squares the input. So this would be f of x squared. And what's f of x? The square root of x. Okay. Big moment of suspense here. What does that equal? Not
The
quite.
absolute value.
No.
X has to be positive.
Very close. That's the closest so far. X could also be 0. So,
You can't take the square root of an angle.
right. So this one, it's the same thing we just talked about, basically. Which is you have to look at that domain restriction before you simplify it. So the actual function is that. Here's a question for you. What shape is that? This is a blast from the past. It's a word you probably haven't heard in a couple of years. Polyhedron.
Tetrahedral, tetrahedron.
Square.
Wait, didn't you just take a quiz on that?
Did you say one of the like that?
I said all right.
Very close.
Hooray.
Who said that? Ah, yes, good. It's a ray.
I don't know.
Because that's a line, right? But if you cut it off at 0, you just have half a line. That's called a ray.
I heard that so many times.
You heard what?
Ray so many times. You said it's blast from the past.
Last year? When did you talk about rays? In algebra 2?
Yeah. This work has talked about rays.
In algebra 2?
Yeah.
In what context?
I don't remember. I just remember hearing the word array several times.
That's like that guy that can like memorize the whole book and he's just like, I don't know what it was about, but I can read it back and tell you.
Yeah.
It's like the guy who won the French Scrabble tournament was an American dude who memorized all of the words in the French Scrabble dictionary without speaking French.
Is that true?
Yeah.
That's amazing.
Did he not know what the words meant?
No.
Did he do it as like a memory flex, like a challenge of memory?
I think so. I don't know. I'll have to look it up again.
There's a community of people that do like competitive memory challenges. They'll do stuff like just who can memorize, say like a
Eddie.
a big deck of cards.
And then
I know.
the people who do memory stuff aren't like special. They just have different ways to remember things. They're like, okay, we'll take these first 5 cards and we'll remember them on this finger. So it goes like this, 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 and this, and then we'll do it on this finger.
You
So
you can biologically do better at remembering things though too.
yeah. You just have to.
Daniel Tammet. You guys know about Daniel Tammet?
No.
He's oh my god, he's an absolute lit savage. This dude is like, he's like a natural savant. He can just remember. I mean, like anything. His abilities are vast. Like he can, you can like give him a book. He can memorize the book. He can like do crazy mathematical computations in his head. He has this crazy mental power. He can like learn new languages really fast.
Lucky. I don't know lucky.
You've heard of Rain Man, right? Rain Man. Dustin Hoffman.
No.
All I know is Rayman. That's a video game character.
You guys ever heard of the movie Rain Man with Dustin Hoffman and Tom Cruise?
No.
Rain Man? You never heard that word? You've seen it? You've heard of it?
We're all zombies.
Zombies. Tom Cruise is like taking care of this guy. It's like a guy with autism, but he also has these like incredible powers of memory and perception. Like there's like a famous scene where someone drops a whole bunch of toothpicks or something, and he like, counts them all before they hit the ground. I can't. You
Oh, I've
guys never
seen
heard of
that.
Rain
I've seen
Man?
that. I've seen that scene.
Or he's like playing blackjack, I think, and he's like counting the cards.
I don't even remember if I've seen a movie with Tom Cruise in it. I know he exists. but
Mission Impossible?
I've never
No.
seen Mission Impossible.
Yeah, no, I don't think
I don't think I've seen it.
Magnolia?
I mean,
No.
No.
Okay, anyway. All right, well, in any case, let's actually do 12 before 11. 12 is a little bit easier than 11. Oh, that's remarkable. The calling someone Rain Man was like a thing because it would be like, oh, if someone was like doing something kind of impressive mentally. Oh, what are you, Rain Man? Anyway, his name was Kim Peek, I think. Interesting name.
That's funny, and I won't stand for it.
Okay, so I'm trying my best to recreate the drawing here.
You got it.
Close enough. 1, 2, 4, 5, 6. Okay, close enough. Okay, so imagine, actually, I guess you don't have to really imagine this one. X. Make a little table of values here. It's a very simple idea here. Right? Hopefully it'll hit you like a light bulb moment. When x is 0, how big is f of x?
Make it 1.
It's positive 1.
Oh, sorry.
This one's f. This one's
Yeah.
1. It's at 1. How big is g of x?
Negative
So how big is f plus g of x?
0.
How do we feel about that?
Oh,
I like
It's draw a
the
line
middle.
in between.
No. How about
So you gotta
yes.
find the line in
Do you
between.
plan out before class how you're going to try to trigger me?
yeah.
Okay. When x is 1, what's f of x?
2,
G of x is?
0.
2?
Oh. Oh.
Addition. Behold, addition.
No. I don't like it.
Behold.
It should be in the
When x
middle.
is 2, how big's f? F of 2 is 3, and g of 2 is 1. So what's f plus g of 2?
Why is it-
Do we understand? How about when x is 3? F's back down to 2, g's back down to 0, which gets us 2. Have we discovered what's going on yet?
It's just stretching.
It's going to do that, yep. Really, all we're doing is we're just taking the two graphs and adding up their
Values.
y values. So at any given x value, you just add up the y values. That's all you got to do. So now, is this how we're going to do it in practice? No. Just think visually. Like, if I add up these two y values, what do I get? 0. If I add up those two y values, what do I get? Oh, well, he contributed nothing, didn't he? If I add up 1 and 3, I get 4. Is this making sense? At 3, back there. Now when we hit 4, we're back to 1 and negative 1, which makes 0. So my graph's going whoop-dee, boop-dee. And what's going to happen when we get to 6?
Going to be back up.
We're going to be back up, and that's going to cross here. See what happened? Now, of course, I want you to draw it on the blank graph. But if you want to, if it helps you to draw it on the left graph as well, that's fine. But draw it on the right graph as well. So how about 11 then? What's 11 going to look like if you go? I'm going to draw mine a little wonky here. If you've got this line and you got this wavy curve. Not a very good drawing. That's okay. Close enough. What, Sean? What's wrong?
Nothing.
What is it?
I'm hungry.
Are you okay?
It's an impulsive line.
Wait, is it just a straight line?
So
Throw it out the
relatable.
window.
That feel when the Among Us is sus. Am I right? Yeah. You fly right into Tilted Towers and you're like, you got a vent, bro. Am I right? Okay. Wait. What's going to happen when you. Now remember, guys, if you just look at the integer x values, I've had people look at this and go, oh, well, 0 plus 0, 0 plus whatever, 0 plus 1. You guys see what the mistake here is?
You're not accounting for in between the things.
Exactly. There's an infinite number of x values here, right? You have to add up all of them. So what's going to happen in between here and here when we're adding up this line and this Humpty Dumpty? You're going to get some Humpty Dumpty action. How about between here and here, where you have this positive linear, and you're adding this like negative hump? It's going to do that. And that pattern continues. Boom, 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 like that.
Yeah, it's like
That's what your graph's going to look like.
That's from me.
Do you see how you're kind of adding the curvy thing onto the line in a sense? This is actually a big concept in like signal processing, where you'll have this idea, like this is just one way it can happen. What do you think would happen if you took like a big wave like this and added onto that a really small amplitude, like wiggly, 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 jiggly like that? If you did this plus this, you'd get, trying my best. I'm trying my best. You'd have the big wave with the little wave added onto it. You'd have essentially like a carrier wave carrying the signal. No one cares.
I think it's cool.
I was too busy with Among Us.
Fair.
There we go, I did it.
What about subtracting two functions? Look at 13. What happens if you subtract two functions?
It just becomes a straight line across too.
Yeah, if you look carefully there, no matter where you pick your x value, f minus g is always 2. So you'd end up with a straight line, a horizontal line. Okay, I hope that all makes sense.
Oh, it should.
How do you guys feel? Fairly straightforward?
Just the minus one.
Look, it just goes this way and then across the edge.
Okay. I want to look at a couple more with you guys before we.
I'm already done that. I've already did it.
You already what?
I already gone. Mentally, I've checked town hall.
What? In any case, let's see. I think the true false ones should be pretty straightforward. I mean, should we maybe discuss a couple just to make sure no one's confused?
Sure.
Like these, like from 17 on, there's very abstract questions. They don't mention specific functions. Like for 17, could you come up with two functions f and g such that f plus g of x is undefined for all x?
The answer is every question. I mean, can you come up with two functions?
Lincoln bio.
I can. Yeah, link in bio.
Okay.
So think about that. Don't even think about actual functions yet. Just think really simply. So I had two functions, right? If an x value can go into f plus g, then it has to be a number that's in the domain of f and the domain of g, right? So how do you come up with two functions where there is no number that can go into both of them? What's like a really simple way to think about that? What?
Two parallel functions. Wait, no.
I'll give you a hint. let's say f is a function that can only accept positive numbers. We know how to make a function like that, right?
It is the E
Square
on
root
the
of
first
x
page
squared.
because it's undefined. I just found an example, right?
E on the first page? It wasn't
Yeah.
undefined for all x though, was it? Or did we have one that was?
It just said undefined.
That one's only undefined at -4.
Oh, okay.
We're trying to come up with one that would be undefined for no matter what x value you
This
pick.
is for
Oh.
negative 4, not for x.
So, you guys get what I'm talking about? Like,
Yes.
can you think, so imagine that f, here's f. Here, I'll draw it on the board. Bootstraps engaged. Ugh. Okay, so we're trying to make this function so that f of x plus g of x doesn't work for any number. So suppose f of x had a domain of only positive numbers. So what kind of function would g have to be then if our goal is that no number can go into both?
Only negative.
Yeah, suppose g had a domain of only negative numbers. Now imagine that. So suppose you pick a number, 5. Can you plug 5 into this function? No, because he can go in there, but he can't go in there. Pick a negative number, -5. He can go in there, but he can't go in there. And 0 can't go in either one. So no matter what number you pick, you're in bad shape. So what's the way to do that? Well, there's a couple of simple ways to do it, like not with these exact domains, but like let's say f was something simple like the square root function. Okay. That can accept, or even let's say it was like this. Let's say it was the square root of x minus 3. So this guy's domain would be only numbers from 3 to the right. Only numbers 3 and bigger can go into him. So let's pick a g function. Let's say that g only wants to accept numbers, say, from like 1 to the left. Anyone?
You just
Negative x squared.
The square root of negative x would work, or say I wanted this to be 1 for some reason, I was going to go like that.
That is how that works.
That's boring you guys to death.
Yeah.
That's bored to death. Sorry.
No, I just forgot how it works.
So this is a pair of functions that would work, right? Test it out. Pick any number you want. 7. Okay, can 7 go in? So the overall, so this plus this, you go, 7 has no problem going into that, but you'd have 7 plus undefined. That's undefined. Say plug in, okay, -10. -10 can go in here, but it can't go in here, so you'd have, with -10, you have root 11 plus undefined, so that doesn't work. All right, you guys. Sorry for trying to show you math.
I'm still on the
How dare you.
matrices things. Why do you need to multiply matrices?
Why?
Yeah.
Because they're there. That's a good answer. No, linear algebra, which is the study of matrices and stuff, is actually probably the most applicable field of mathematics right now. That and statistics. Because if you have, say, you have a huge array, a bunch of data, millions, right, millions of pieces of data. How do you analyze that? Well, you put them into these big matrices, and then you manipulate the matrices using mathematical operations, and it gives you information about how the data behaves and stuff. So,
Sweet.
graphics too. Machine learning, AI stuff is all based on
I get
calculus and linear algebra. That's the main idea is, yeah, if you want to have a whole, because the matrix can be huge. It could be 100 by 100. Let's talk about 18.
I don't like 18. It scares me.
Yeah.
You guys are killing me today. Why have you done this?
I'm sorry.
Use a bootstrap.
I'm bootstrapping right now. Okay, bootstrap, boom! 18. Okay, put this into plain language. What are we talking about with f and g here?
F is greater than X, G is less than X.
No.
Sorry, F is greater than 0, G is less than 0.
Right, so f is a function where all of his y values are positive. G is a function who all of his y values are. Okay, so to visualize that, what's my graph going to look like? If I want to make a graph that's kind of general, won't confuse me, won't lure me into a false trap. F could I draw my F like this?
Mm-hmm.
Does that fit the description of F of X
No.
is always positive?
No. Cut off the left part.
This part?
Yeah, right?
No, I didn't say, don't confuse this with saying that X is always positive. Remember how F of X means it means the output of F.
Mm. So if the
This
Y
says the
value-
Y values are always positive.
Yep, that works.
So this works. As long as there's no funny business of me being like, oh, actually it goes down here. How about G? When we say G of X is always negative, that means the Y values of that function are always negative. Do we understand?
Mm-hmm.
Okay. So do we know anything about F plus G? Anything about adding those functions? For example, true or false, F plus G of X will always be positive.
False.
That's false. Look right here, the way I drew it, this F value plus this negative G value would not be positive, right? Because the negative value is bigger. Now, this is interesting. How about F of G?
We know that it has to be negative.
What?
Negative X.
F of G of X.
Something I
Always be, F of G of X will always be positive? That's true. That is true.
Oh, yeah.
Let's go through this argument,
Yeah.
okay?
No, it makes sense.
You'll see these questions are, it's still mathematics. It's more, mathematics is the core of philosophy, but this is getting more philosophical, logical than, say, calculation-based. But anyway, this is true, right? F of X is positive. F of anything is always positive, right? So then let's examine what happens if you go F of G of X. Well, what kind of number is this going to be?
It's going
A
to be
negative number.
number.
But isn't F of a negative number
Still positive.
going to still be positive?
Yes.
So this is always going to be positive. Now, there's a key here that's very important, which is it says that this is true. These statements are true for all X, meaning they have, what's the domain of both functions?
All number.
All reals. So what we can be assured that I know that this is going to spit out some kind of negative number. And I'm also certain that F can accept a negative number as an input. And I also can be sure that no matter what number that is, F will always output a positive number. So do we understand the answer? Yeah. So that's the answer. Okay. How about G of F of X? That will always be a negative. And how do we write that statement? Right. You can write it like this, for example. G of F of X is always negative. Are these confusing? Kind of. That's a good answer. Well, because I think if you think these are super simple, you're either it just totally clicked in your mind, or you're just deluding yourself into thinking it's easier than it is. How about F minus G of X?
Always positive.
Because you're subtracting negative numbers.
Yeah, a positive. Pick any X value you want. You're going to be doing a positive minus a negative.
Oh,
How about G minus F?
always negative.
How about F divided by G?
Always negative.
Why?
Because you have a negative denominator, which means negative fraction.
What if I said we can't be sure if F over G is defined? Because I say, what if G was 0?
And
Can't be
zero.
Owned by facts and logic. There you go. G cannot actually hit 0, so G can never be 0. Good. Well done. Well done. Let's see how much time we have left here.
We have 2
Just a
minutes.
minute. It's okay. I'm going to cover the charty charts and stuff tomorrow, but last couple of remarks here. Look at 19. If f of x is the square root of x, and f of g of x exists for all x, then what has to be true about the function g?
It's always positive.
That's
And
close.
it's greater than or equal to 0.
Yeah. I'm actually thinking, wondering just logically, could you say it must, you can't say that g must be, say, greater than 0. Sorry, that's really nitpicking. So you know that the g function has to only have, it can't have negative outputs. Otherwise, there'd be a potential for g of x to be negative, and you can't take the square root of that. So, oh, 20 is interesting. If the function f of g has an all real numbers domain, is it necessarily true that f and g both have domains of all reals? If so, explain why. If not, provide a counterexample. Thinky?
Yes, you can't have one undefined over such a. Both of them have to be defined for you to have values.
I'll give you the answer. It is not necessarily true that f and g both have domain of all reals. Hunter's very excited about this one. So number 20, that's just a hint. The hint is it's not necessarily true that both of them have to have domain of all reals. There's maybe one of them. Maybe one of them needs to have a domain of all reals, and the other one can get away with not having a domain of all reals. Okay? And there's something here about range. Anyway, I think you guys will figure it out. You're all smart beans.
Yes, I just think being smart.
You what?
I just